Okay, so we're going to take a look at some of the problems you'll see in section 11.2 now that we have area formulas for triangles, rhombuses, and trapezoids. Here's a little triangle problem, number 13. Now I've added a couple numbers to it, a 5 and a 7 for the lengths of the other two sides. They may not be entirely accurate, but the reason I want them there is that when you see problems like this on quizzes or tests, you're going to have to decide what's the base and what's the height of the triangle. And there won't just be two numbers like there are in this problem. Okay, so what we've got going on here is a triangle, and I hope that you can see that the height is the 3.4. This guy right here is the height of the triangle. It's the height because it's measuring the distance from a vertex and forming a right angle with the opposite side. That makes it the height. The side that it's forming the right angle with down here, the 7.3, is the base of that triangle. So the formula for the area of a triangle is 1/2 of its base times its height. So that means it's 1/2 of 7.3. Might as well make that prettier. 7.3 times 3.4. From our calculator, we get that that area is 12.4. That's rounded to the nearest tenth. The next digit was 1. And the correct unit, since I was dealing with centimeters to start with, are square centimeters, which we write as cm with a squared symbol above it. Okay, on our next problem, we have a trapezoid. Okay, terminology, well, first of all, let's write the formula down. The area of a trapezoid is 1/2 of its height times its bases added together, B1 and B2. The bases of a trapezoid are the parallel sides. So that's what the little arrow marks mean. So one of my bases is 16, the other base is 24. Doesn't matter which one you call B1 and which one you call B2, they're just two different bases. Now, the height of a trapezoid is the distance between the parallel lines. Distance is measured at right angles, so again, it's the dotted line there that has a length of 12 yards. That is the height of the trapezoid. So we're just going to plug directly into our formula. The area is 1/2 of the height, 12, times the bases added, 16, plus 24. Now we could go to a calculator if you want to, but I know that 1/2 of 12 is 6, and I know that 16 plus 24 is 40, so this is 240, and the correct units are square yards. On our next guy, we've got a rhombus, and we've come up with a special formula for the area of a rhombus in terms of its two diagonals. As I said, our next figure here is a rhombus, and we have a special formula for its area in terms of its two diagonals. In this picture, they're showing us that DE is 24. Well, if DE is 24, then BD, which is one of the diagonals, must be 2 times 24, must be 48. That comes from the property that the diagonals of any parallelogram bisect each other. So if you have one 24, you have another 24, and over here if you have this 20 that the arrow is pointing to, you've got another 20. So the length of AC must be 20 times 2, it must be 40. The formula says that the area is 1/2 of D1 times D2. So in this picture, the area is 1/2 of 40 times 48. Again, you could grab a calculator, but I know 1/2 of 40 is 20, and that would be 20 times 48, and that's 960. Your correct units would be square meters. Okay, on this one, we just have a quadrilateral. That's all we've got. It's not a rhombus. There are no parallel sides. It's not a trapezoid. It's not a parallelogram. It would seem we don't have a formula for it. But we have the property that if I can divide a figure into things that I know, I can add up the areas of the things I know to get the area of the total figure. And that's what's going to happen here. We have in this figure, this quadrilateral, a couple different triangles. We have this triangle that I'm outlining in orange. Okay? Triangle FGH. The area of triangle FGH is 1/2 of its base times its height. Well, the 9 inches is measuring the distance from G down to the opposite side, which is FH. So it will be the height. That 9 will be the height of that triangle. The base of that triangle is segment FH, and they've told me that's 37, so that will be the base. So we get 1/2 of the base, 37 times 9. Now, I'm not that smart, so I'll do that one on my calculator. And that would be 0.5 times 37 times 9. Okay, this is 166.5. Okay, the area of the other triangle, the area of triangle FHI. We'll outline him in a different color. Let's go with purple. Okay, here is that triangle now. And it has a height. Its height is the 18. It's a height because it's measuring the distance from vertex I to the opposite side, FH. And that's great because we have the length of FH. So the area of this triangle is 1/2 of its base, which is also FH, is 37, times its height, which is 18. Well, we'll go to the calculator, although I can see that's going to be twice as big as the other guy because it has twice the height. But we'll go ahead and calculate that. 1/2 of 37 times 18 is 333. So the total area of quadrilateral FGHI is the area of its two parts put together. So that would be 166.5 plus 333. And that's 499.5. And the correct unit would be square inches. Okay, number 30 is a little different sort of problem. On 30, we know the area, and this happens to be a trapezoid, and we're asked to find the height of the trapezoid. Well, this is just a little algebra problem where you're working it backwards. The 35 here would be one of the bases, B1. The 25 is the other base. Let's call it B2. The dotted line again represents the height. It's the distance between the parallel sides. Go grab the formula. It says the area is 1/2 of the height. We don't know the height. Well, it's 1/2 the height times the base is added. So that's the formula you should have written down. So now substitute. In the place of area, put 750 because that's the area. Equals 1/2 of the height. Well, the height I don't know. That's what I'm trying to find, so I'll leave a variable. But I know the two bases. I can just fill them in. They are 35 plus 25. And now you've got a little algebra problem to solve. This is equal to, and there's a lot of ways to do this. I'll go ahead and add the two numbers in the parentheses. That's 750 equals 1/2 of h, and that'd be multiplied by 60. Well, I can take half of h, but I can also just take half of 60. So this is 750 equals half of 60, which is 30h. If we divide both sides by 30, we get the height of this guy. 750 divided by 30 is 25. So the height is 25, and since we started out with meters and everything else, we're going to be in meters here. 25 meters. Okay, one more example. This time we're given a rhombus, and we know its area. We know one of its diagonals. MP, this segment here, is a diagonal. We know that it is 25. Now, what it's asking for is NQ, which is the other diagonal. Well, we'll just put a variable on that other diagonal. And what I mean here is that X is the whole deal, because 25 was the whole other diagonal. Okay, so again, you take the formula. Area for a rhombus is 1/2 of its two diagonals multiplied. In the place of area, A, put the 375. Equals 1/2 of, one of the diagonals is the one they told us is the 25. The other diagonal is the one we're trying to get, which is segment NQ. Let's just call it X. Okay. Do what you like. This time I'm going to multiply both sides by 2. If I do that, the left side becomes 750, and the right side is just 25x. After I multiply the right side by 2, the 2's cancel. Now divide both sides by 25, and you get your value of x. And the answer is 30. So NQ, which is what they wanted to know, is 30, and since we started off with square inches, this should be inches for its measurement. Well, at this point, you've got an example of everything you need to do the problems in section 11.2. Have fun. After all, it's math.